This is Adam, and he wants to deploy resources on his cloud hosting provider, that is AWS. And for that, he chooses Terraform, and that's a good thing. But how does Terraform know where and on which platform he's trying to create those resources? That's a confusion, isn't it? And that's where we need to talk about providers. And let's understand what are providers and how they can be helpful. Hello everyone, and welcome back to another session on the Level Up series for DevOps. And today we will talk about providers, and we will create our first EC2 instance using Terraform. So if you're ready, let's begin. And providers are basically a logical abstraction of an upstream API. They are responsible for understanding API interactions and exposing resources. Quite a mouthful, isn't it? And some of us may need to learn what these terms actually mean. Don't worry, let's talk about them. Let's take a very simple example, and you can tell me in the comment section if you got this. Imagine there is a shipping company that works alongside this river, and we have an owner, which could be you as well. Here we have point A, which actually provides the products that we need to ship to the customer at point C. And we have point B, which is our packaging plant, which packages and loads it to the ships which eventually reach the customer at C. So the design basically that you're seeing here is starting from A, then it moves to B, then to C. That's our design. And if you see this, for the product to be sent to C, B has to collect the raw product from A, and then based on the requirement, it has to send it to C, something like this. So the point A to B is your upstream, and point B to C is your downstream. And that's how APIs work as well. Now look at this. The customer sends the request to the plant for the product with the requirement dataset. The plant needs the data to process it, so it takes the data and sends it further to the actual production plant for the required product. And based on the data that B had provided, plant A checks for the product and sends it back to B. And then B sends the information collected to the point C. That, in case if you're using APIs, is a response data. And that is why it is the upstream, and the response callback is the downstream. And that's how APIs work. And if you're still not clear, let's see another example. Suppose we created a food delivery app, which gets the cheapest food from all the restaurants and sends it to you based on your food choices. So this app, basically what it does, it actually collects the cost for the food that you have from all the listed restaurants, and it checks the prices of the dish in all the restaurants, and it collects the data and sends it to the user. So the user sends the request using its app to the server. The server collects the data from the restaurants and sends it back to the user. And here as well, you can see the user needs to send the data with the context to the server for it to process. And without that, the server cannot do anything. And the server also needs to have the data the user needs. That is why it is called a request and response architecture. And that is why providers are the logical abstraction of an upstream API. They are responsible for understanding API interactions and exposing the resources. So it hides the background details and just exposes resources you can use. So the API would need certain information from the user who is performing the operations, like the authentication, the region for which you want to deploy the resources, and other configurations. As it is mentioned here, providers are the plugins that Terraform uses to manage those resources. Every supported service or infrastructure platform has a provider that defines which resources are available and performs API calls to manage those resources. Yes, providers are basically nothing but plugins which have the capability to perform operations on your behalf based on your requirement. So here, supported services and platforms like Google, AWS, Azure have their own providers which actually have the resource call to manage the resources on the cloud. And similarly, we have thousands of providers which you can make use of. And that is why Terraform is an infrastructure as code tool. And as a developer or engineer or someone who needs to work on Terraform, remember these points very carefully. First thing is to scope. You should be clear on what you want to deploy. Scoping the infrastructure that you are deploying into and the resources that you are deploying are really very important. You should know what you are trying to deploy. Second, author. Write the configuration for your infrastructure that you will be feeding it to the tool. It could be the environment variables, it could be credentials, it could be a template that provides you the data needed for the type of resources you are creating, like the AMI ID, VPC ID, security group ID, instance pool, or it could be the subnet CIDR. Third thing, initialize. So in initialization, what we do, we install the plugins Terraform needs to manage the infrastructure. If you're using AWS, you need the AWS provider. And if you're using a specific module, you need to import it as well. Fourth, plan. Plan is also very important, which is also a very important part as well, where you will preview the changes Terraform will make to match your configurations. So make sure you're going to deploy the right configuration. And once you preview and once you accept, then only it can be deployed. Fifth, very important as well, apply. So the fifth point that we have is apply. Once you're done with the planning phase, just hit apply and you apply the changes. And that is when the resources get modified or created or deleted based on the operations that you have. And these 5 points are really very important. Make sure you always remember this when you work on Terraform. Now let's do a quick recap on the things that we have learned till now. So till now, we know that Terraform is our infrastructure as code tool that provisions, updates, and destroys infrastructure resources such as physical machines, virtual machines, network switches, containers, and many more. And providers are our plugins that Terraform uses to manage the resources. And the next thing is what we actually write. That is the Terraform configuration. So configurations are code written for Terraform using the human readable HashiCorp Configuration Language, HCL, which is used to describe the desired state of the infrastructure resources. Yes, we will write HCL we will use HCL to write our Terraform code. And also there are modules which are available for us to use, or if we want, we can write them as well. So modules are the reusable configurations already written for us for our use, which you can make use of, and you can modify them as well and make use of them for your deployment, which you can also call as code templates. And there is another important thing which is called the Terraform registry, which will help us make use of the providers and modules. Think of this like a documentation for your providers and modules, like a user manual. You can also call this like a user manual for using Terraform providers and modules. And registry will also help you as it provides plugins to manage any infrastructure API and pre-made modules to quickly configure common infrastructure components. And it will also provide examples on how to write quality Terraform code. So Terraform registry is the place for us developers to go. Don't worry about the Terraform registry and modules now. When we work on the demo, you will get a clear picture on how to use them effectively to work with Terraform. So I hope you got the point here. Let's move on. So now what you can do is you can just go to Google and just type Terraform and go to terraform.io's website, Terraform by HashiCorp. Yes, this is the one. And here you can see registry. Just click on that. So as I told you before, like registry is a placeholder for our modules and providers. And this is one of the websites you will be using thoroughly, I guess, whenever you're working on Terraform. So if you see here, we have a browse providers, browse modules. So if we go down, you will see the some of the information about the providers and some of the modules as well, specific modules. So the first thing that I want to do is I want to go to providers. So just right click on browse provider and open it in a new tab. So this is the page for your Terraform providers. So as I already told you, providers are a logical abstraction of an upstream API. They are responsible for understanding API interactions and exposing the resources. So using Terraform registry, we will get hold of all the providers and the modules that we need for our AWS deployment, because we are going to work on AWS. I'm sure I was clear before as well, like we'll be working on AWS. So I hope that's not a surprise for you here, because we were working on AWS and I wanted to continue working on Terraform with AWS itself. But you have AWS, Azure, Google Cloud Platform, and you will find it interesting that most of the things that we will do will be similar for the cloud platforms that we have here. So the first thing that we need to do is we need to go to providers, just click on AWS. So when you click on this, you will see the AWS provider, which actually tells us that it manages, or the lifecycle management of AWS resources, including EC2, Lambda, EKS, ECS, VPC, S3, RDS, DynamoDB, and more. This provider is maintained internally by the HashiCorp AWS provider team. So that's a very good thing, because they'll make sure that it is updated all the time. And one thing that you have to understand here is providers, as it is mentioned, lifecycle management. So you can manage the total lifecycle, in the sense like you can create the resources, you can update the resources, you can actually delete the ones that you have created using Terraform, and you can also manage them. And that is why it is said that it is a lifecycle management of AWS resources. So from the start, from once you create it, you can modify them and as well as delete them using the providers. So the first thing that we have to do is we have to use this provider. So let's suppose I click on use provider here, and I'll just tell you that this is similar for Azure and Google Cloud Platform. I'll just show it to you. So here you see lifecycle management of Microsoft Azure using Azure Resource Manager APIs, and this is also maintained by HashiCorp, and it's same for the Google as well. So let's close these two. We don't need them. We need AWS. So just click on use provider. So here, how to use provider? To install this provider, copy and paste this code onto your Terraform configuration, then run Terraform init. So this is the first step for us. For Terraform to know which cloud hosting service we are using, we have to make sure that we add it to our Terraform configuration. So if you are using AWS, we will add the provider for AWS. If you are using Google Cloud Services, we will use Google's one. And if suppose we are working on Azure, we will make sure that we use the Azure provider. And if we are using multiple ones, we'll check that out later on. So don't worry about that. We'll get to that as well. So go to the documentation here. And this is a very good documentation that Terraform provides. But sometimes what happens is when you're working on complicated stuff, you may not get this elaborate information from this document also. You might have to do some Googling there. And I'm not sure if you'll be able to find the references, but at least you'll get some hints onto how to configure the specific resources that you have in your mind. So what we have here is, so use the AWS provider to interact with many resources supported by AWS. You must configure the provider with the proper credentials before you can use it. So this is a very important step. So you need to configure the provider with the proper credentials before you can use it. Because see, if you're using AWS, it doesn't mean that it will know like where exactly. See, AWS is a cloud hosting platform, and you are not the only one who is using AWS, isn't it? But it has to know that we are going to deploy this resource into this specific account for this particular region for this particular user. So it has given here, see, if you see Terraform 0.13 and later, you have to use this syntax. If suppose you have a Terraform version of 13 and later, you have to use this, and 0.12 you have to make use of this syntax. Wait, we'll do this, don't worry. And next comes authentication and configuration. So this is also very important because, and that is what I was talking about, like authentication. Configuring for the AWS provider can be derived from several sources, which are applied in the following order. First thing that we need to do is we need to add the provider for AWS so that Terraform knows that we are working with AWS, and then we'll provide the access key and the secret key. So this is the basic idea of providing configuration. But as you can see here, it has written that hard-coded credentials are not recommended in any Terraform configurations. So let's suppose you added this access key and the secret key, and you committed the code and you pushed it. And let's suppose that's a public repository, so anyone can actually use it. So that's a very bad thing. So we should not do this in real time, but just for our example for today, so that we can save some time for this session, we will do it using this access key and the secret key. So what we're going to do is just copy this one. And I think most of you might be using Visual Studio Code. So I will also use that to keep it simple. So last time we had created a folder called Terraform code, within which I had mentioned or within which I had created a main.tf file. So what I'm going to do is I'm just going to delete this and I'll just paste the information here. So the Terraform required provider is AWS. The source is basically HashiCorp/AWS. The version is 4.0. And the configuration that you can see, configure the AWS provider, we have the provider here. So the default region that you see here that has been mentioned is US East 1. So I'll change this because I want to use US West 2, and that's where I want to deploy my resource. And this is the way actually Terraform will know that where exactly we want to deploy our resources. So just let us keep it here. We'll not go into much details on this as of now. We will talk about this later on in the upcoming videos where I'll talk more about the configuration and the resources. So at that point of time, we'll discuss more about what exactly this block is. This block is basically nothing but it tells you what provider we are going to use and what exactly is the difference with the previous version and why they have made it this way. So I'll talk about this as well. So don't worry about that. So let's go back to the documentation. And let's go back to this particular simple credential provision. And once we have copied this, and you might ask me, where will I get the access key and the secret key? I'll tell you, don't worry. So this part is done for us. And the access key and the secret key that we'll get will be replaced by these placeholders. These are just dummy. We will replace them with the actual values. So let's go to the AWS account. So this is my AWS account. And I hope you are also having a free tier AWS account to work on this. I'll provide the link for the video to create a free tier account on the description. So you can also check that out if you don't have it. So let's go to IAM. And this is my admin account. So obviously I'll not use the admin account to work on Terraform. So what I'm going to do is I am going to create a user. So to create a user, what I'm going to do is I'm just going to click on add user. So you have to come to IAM, click on users, go to add user and just give it a name. So let's suppose this is developer. So this is a developer account that I'll create. So select AWS credential type. So I'll give access key because that's what I need. So programmatic access also I need, and I will assign it a password as well. And don't use this particular option. User must create a new password at the next sign in. You don't want that. Just remove it. Okay, so I've given the custom password. Next, I'll just go to permissions. So I'll just directly attach the EC2 policy here. So Amazon EC2 full access, because I want to create the resource. Click on next tags. Just provide a value. Develop. Name is develop. This is one of the tags that I wanted to give. It is optional. It is not mandatory that you provide tags. Okay, so let's review this. So review your changes or choices. After you create the user, you can view and download the auto-generated password and access key. So once you have created this, you can actually download it. So the username is developer, programmatic access and AWS management console access. So that is the access type. And console password type is custom, requires password reset no, permission boundary is not set yet, but I have given a managed policy, the AWS managed policy, that is Amazon EC2 full access, because I am going to work only on EC2. So this is what we call as least privilege. Because I want to work on EC2, I'll just provide that particular policy, but you can also minimize that to only certain operations. I'm just giving you an example. So now just create the user. Okay. So this is the golden words that you have. So this is the access key ID and this is the secret access key. So download this CSV file. This will have the information about your access key and the secret access key. And once you've saved this CSV file will look something like this. You'll have the username as develop. You'll have the password. It will not be there here. Don't worry. This is the access key. This is the secret access key. So I'll just update these values in the document or the code that I have, and I'll just show you how it is. So now I have updated the region access key, and the secret key. Okay, before moving forward, because we got the access key and the secret key, what I would do is I'll just remove this. So let it be like this: provider AWS region US West 2. The first and foremost thing for you is to understand the resource configuration. Let's suppose I want to create a EC2 instance. So what it would need. So let's click on launch instance. So the basic requirements to launch an instance is first to give a name. Then the next thing is to choose an operating system image that you want to create the instance for. So let's suppose we choose Amazon Linux, and here we have to choose the AMI, so which is basically our pre-tier AMI. And so let's suppose we chose this, we need to choose the architecture, and then the most important thing would be the instance type. So as this is the free tier eligible, we have another free tier eligible now, which is t1.micro, and obviously we had t2.micro, we have been using this, so this is also a very good option. So these are the two things, basic things that we need. So first is the AMI ID, and the next one is the instance type. So this is t2.micro. And now what happens is we need key pair also if we want to log into that, and we have the network settings like VPC, subnet, like auto assign public IP. There is a boolean here whether you need to enable or disable it. You can actually create new security group or select the existing security group that you already have. All these things that you have are basic default, so they come with a default configuration. So even if you don't add these things, they will not be mandatory. And how do we know that which configuration is mandatory and which configuration is optional? So that also the provider can give you. So here you can find EC2. Here you can find almost all the services that Terraform supports. So what we need EC2, isn't it? So this is the EC2 Elastic Compute Cloud. Just click on this and you see all the resources. So we have AWS instance here. So just click on this. It'll give you an example of how you can use it. So what it is trying to do is it is trying to compute the value of a particular AMI, and it is trying to give you. So what if we don't want to complicate things for now? Let us just create a simple EC2 instance. So just copy this. So just copy and paste it here. So this is the resource. So what kind of resource we want to create? We want to create a AWS instance. So this will be constant. You should not change this. But you can change this because this is a resource name. This is a resource name. So it is like bread and jam. So this will be your resource type, and this will be your resource name or reference name. I'm telling you once again. So the one that you're going to create is your resource type. So I hope you got this. So you can change this as well. So this is my resource type and this is my reference name. That name will be different from the name that you have here for the resource that you are going to create. So this will be different. Now, as I don't need this, I'll just delete it. And you must remember that each AMI is specific to a particular region. So if you're working on US West 2, make sure that you have an AMI that is from that region itself. Otherwise, it will throw an error. So make sure that you select the AMI from that particular region itself. So I am working on US West 2. I'll just click on this. So this is the US West 2, and that is what I'm trying to deploy the resources on. And I'll copy this particular AMI and I'll just come here and I'll paste it in quotes. You can see here the HCL language doesn't require you to put a comma here. And also let us give a tag. Okay, let's give a tag for this one. Okay, so we have the credentials now and we have the resource that we want to create. So there's the resource block to create the EC2 instance. Let's give it a name. Let's comment this as well. Create EC2 instance. So as I told you, you need to scope it, you need to plan it, and then you need to apply it. I hope you remember it. So go back to the terminal once again, and let's go to this particular path. So this is where I have the main.tf file. So if you do a dir here, and you will find the main.tf. Let's do a CLS. And now the first thing that we need to do is to install the provider, copy and paste this code into your Terraform configuration, then run Terraform init. We need to run that particular Terraform init command. Terraform init. And just hit enter. So now as you can see, it is initializing modules and you would see a small .terraform folder created. That is what happens when you start initializing. So now it is downloading registry.terraform.io. It is downloading the AWS modules EC2-instance because I was creating it. So initializing provider plugin, finding HashiCorp/AWS version matching 3.72, installing HashiCorp/AWS version 4.49, and it has installed properly. And now what happens is, and you can see here Terraform has created a lock file. So we will talk about this, don't worry. So this is used to prevent modifications. I'll tell you why it is required and why is it very important in production environments when we actually use Terraform to deploy resources. So now once you have done the Terraform init, let's do a CLS and let's do a Terraform plan. Now when we do a Terraform plan here, what it is saying that invalid provider configuration, provider registry.terraform.io requires explicit configuration. And let's copy this block. So that is why I told I'll just remove it for now and I'll show you when we plan it. Now let's save it and let's do a Terraform plan. So now as you can see here, it has created two things. One, it has created a .terraform folder. The other one is terraform.log.scl. So these two are very important. We will get inside these two and we'll see what exactly it has. So now this is very interesting. See this. So once you've done a Terraform plan, what it is telling you is please review these changes. Terraform gives you an opportunity to actually see what exactly you're going to change. So resource actions are indicated with the following symbol. So plus, wherever you see green plus is the one that is getting added. So it is a create operation. And what it is creating now? So it is creating AWS_instance.terraform demo instance that will be created. And this is the resource configuration. So the AMI is the one that we have provided. And the other things that you see here, ARN, associate public IP address, core CPU count, all these that you see here have been mentioned known after apply. So known after apply means they will be available to us once the resource is created. So once you have created the resource or once the Terraform has created this resource, these values will then be populated and we'll get to know about them later on because these were optional values. And that is one thing that I forgot to mention. So let's go back to the instance type. So as you can see here, this is the basic resource configuration for the EC2. If you go down, you will see an argument reference. For every resource that you are going to create, you will find an argument reference and please make sure that you use it. Okay? Because it will give you all the supported arguments list that you can use during the creation of that particular resource. So let's suppose we used AMI, which is optional. So there's the same variable that we are going to use or the same argument that we are going to use. So that is AMI. And you must read through all these argument references. So as it is giving here optional, if you think it is optional, then you should read this whole thing. So AMI to use for the instance, we have provided this and it is required unless launch template is specified and the launch template specifies an AMI. If an AMI is specified in the launch template, setting AMI will override the AMI specified in the launch template. So it is required unless the launch template is specified. So here we have not specified any launch templates. We are just going to provide the particular value to the AMI. So here you can see plan 1 to add, 0 to change and 0 to destroy. So let's suppose you're creating a resource. So the ones that are going to be created, it will take a count of that and it will give the number here and it will tell that these many are to be added. But on the other hand, sometimes what happens is we are going to modify the existing resources. So in that case, it would mention the count here to change. So because it is changing an existing resource, and let's suppose you're destroying something or deleting something using Terraform. So here it will show you the count on the number of resources that we are going to destroy. Now the next thing is for us to apply. So just type Terraform apply. You can also do a Terraform apply itself without planning. It will show you the preview state and it will directly give you the option to deploy it by asking you enter a value yes. So Terraform will perform the actions described above. Only yes will be accepted to approve. What if we do no? Apply is cancelled. So that is something that we don't want, isn't it? We want to apply this change. Let's do it once again. And now we have previewed it. Just type yes and press enter. So now AWS instance.tf demo instance creating. So it'll take some time to create this instance, like 10 seconds, 20 seconds, depending on the network speed or the speed at which AWS is running. So that would help us create this resource. And the best practice is basically to separate out the provider file and the resource files. And we will talk about them later on as well, because I'll show you how we can do that. So now you can see apply complete, resources 1 added. Congratulations, you have successfully created your EC2 instance on AWS. So now we have to validate this. You can see we have got the ID. ID is 0CD3 and B0E8. Let us copy this. Find this. Yes, this is the one that we have created. Click on this. So there's a public IPv4 address. There's a private IPv4 address. We didn't provide anything, but it has created everything by using the default values and the tags at the end. Name Terraform demo instance. This is the name that we have given here. Let's perform the Terraform plan again. So refreshing the state, it is trying to pull the information for that particular ID that was created. So no changes. Your infrastructure matches the configuration. Now you might be thinking, I haven't given the instance ID in this particular configuration, but still it is not creating a new instance. Why is that? Go to this file. And this is where it stores the information about what has been created and by whom. And this is how it preserves the state. And that is what I was saying, that the idempotency in the infrastructure deployment tools are very important. So if you see the TF state file here, so this basically gets created once you perform an apply operation. So if you can see here, we have the Terraform version 1.3.6. You come to the resources that have been deployed. So you have the AWS underscore instance, TF demo instance. And if you go back to this particular attribute, you can see the AMI that we have used and the ARN for that particular instance. If you come down here, you will see all the values populated based on what we could not find when we actually were performing the apply. So once we had created this, the state file actually captures those values. CPU core count, associate public IPv address, IP address true, availability zone, reserve capacity reservation specifications, disable API stop false. All these information we did not give it. It is getting it from the instance state itself. So now if we do a plan again, it is saying that no changes. Your infrastructure matches the configuration. Terraform has compared your real infrastructure against your configuration has found no differences. So no changes are needed. Let's go back to the AWS instance and I'll go to tags. I'll go manage tag and I'll just remove this and I'll just save it. This is a very small change that I've done. I've just removed a string or a portion of a string from the tag. Let's see if Terraform is able to detect it or not. So for that, what we need to do, we'll just hit the Terraform plan again. Just hit enter. It will go and fetch the information. So here you can see the resource AWS instance tag has been changed to Terraform demo. Previously it was Terraform demo instance. And there are 29 unchanged attributes that are hidden and 7 unchanged blocks hidden. The plan is to change one value. So this value that is coming from the server will be changed as per the state file because the state file has this particular name. So if suppose you go ahead and do some manual changes in that particular instance, we can actually restore it because we have the state. And that is how it maintains the state of that particular resource. And this is a very small example that I'm giving. You won't believe the amount of resources and the resource blocks that would be there when you're working in a real-time Terraform environment. We will do a Terraform plan again. And what we're going to do, we are going to apply this change. Now, the next thing that we have to do is, yes, we have to type yes and hit enter. So here it will change because this is the existing resource and we're just modifying something. Now the change has been applied. The resources added 0 because we've not created any resource. We have just changed it. So 1 changed and modifications complete after 4 seconds. Now let's go back. We'll just refresh this. When it comes to tags, you will find name Terraform demo instance. And now, as I already told you that we can perform a complete lifecycle management for a resource, let's try and delete this. So just type Terraform destroy target equal to the resource type is AWS underscore instance dot. I'll just copy this like this. You can perform a plan operation like this also, but let us just do for destroy. Let us see what happens. So it is trying to access the target value for us, which is AWS instance Terraform demo instance, this particular resource. It is saying that AWS instance Terraform demo instance will be destroyed. Come down. Let us just go back and I'll just perform a Terraform destroy. See here, when you come down here, you will see one to destroy, because the only resource that I'm going to delete is that particular EC2 instance. So do you really want to destroy all resources? Just hit yes and just hit enter. And one more interesting thing that I would show you here is you can see Terraform tft.lock has been initiated here. During that execution, it would be in a lock state. Once the execution is completed, you will see the lock will be removed from that particular state file. So one resource is deleted. Let's go back to that particular EC2 instance. So this is deleted and we have cleaned up the resource. So today we created an EC2 instance, we modified an EC2 instance, and we deleted an EC2 instance as well. For now, just don't worry about the external things that you see here. Just try and practice with your AWS free tier account to create a EC2 instance, add the provider, add the credentials. Don't share these credentials with anyone, and make sure that you terminate the resources that you create, because you will be charged if you forget that. And remember the region that you're going to create those instances or any resource that you create, because most of the time people forget the region that they have created the resource, and ultimately they get charged heavily by AWS on their free tier accounts. So don't make that mistake. Remove all the resources, terminate all the resources once you are done playing around, and you should be good with that. So that was a very interesting session. I hope so, and I hope you enjoyed it as well. And this would be one of the final theoretical sessions, and from now on we'll only be focusing on the hands-on demos, because that's what I want you to do. So that is what I wanted to share with you as well, so that your expectations are straightforward, like you are going to perform hands-on demos from now on. And that's what we are going to do on this channel. And I hope you enjoyed this session, and I hope that you will be back for the next session as well. And if you did like this video, then please make sure that you like the video. And if you're new to the channel, then please make sure that you subscribe. That really motivates me. And please do comment on what you liked, what you didn't, and what you would like to see on the upcoming videos as well. So I'll meet you in the next one. Stay safe, stay healthy. It's Pythoholic signing off.